Welcome back, guys and gals. Here we're looking at video 3.2, which is going to be on the properties of matter. Main objectives: make sure you compare and contrast the physical properties that matter may have. Just a reminder to turn off your phones, social media, pause, rewind frequently, and to take some notes in your margins should you have questions later. Let's go. So physical properties. Physical properties are characteristics that are observed or measured without changing what the substance is. So here's some examples of things you can measure or observe without changing the substance. You can tell what color something is. So for example, water is colorless. The density of water can be measured to be 1.0 grams per cm cubed at room temperature. Water, it has no odor, it's odorless. Hardness doesn't apply because it only applies to solids. Water is a liquid. Melting point, well, ice will melt into water at 0. So another way to think about that is the freezing point is 0 degrees Celsius as well. The boiling point of water boils in the steam at 100. And then state of matter. What state of matter is the substance currently? In this case, water is currently a liquid. So physical properties are basically things you can measure, observe, without changing what the substance is. So it's got to be H2O. Physical properties can also depend on the amount of matter. Some of those properties we just talked about there. The properties that do depend on how much the amount of substance you have, we call those extensive properties. And properties that do not depend on the amount of substance, we call those intensive properties. So does not depend on the amount. So for example, let's kind of go through some of these. So color. Does the color of water depend on the amount or not depend on the amount? And the answer is does not depend. So color is what we call an intensive property because it does not depend on how much water you have. The density of water. Will water become more or less dense if you have more of it? And the answer is no, it does not. So that's intensive. Volume. Does volume change if you have more water or less water? And the answer is yes. Water does change the volume if you have more of it. So that's an extensive property. It does depend on how much you have. So does mass. That's an extensive property. Melting point. Does it matter if you have a cup of water or a gallon of water? Will it melt or freeze at a different temperature? And the answer is no. So that's an intensive property. And same with boiling. That's intensive. Good example here, like if you have a cup of water or a gallon of water, basically this will boil first before the gallon will because it takes less energy to heat up that small amount of water, but they will both boil at 100 degrees Celsius. So just a little more on physical properties being extensive or intensive. Chemical property, not really something that's the most important part, but it's basically the ability or the inability to change into one or more substances. So the way you'll see these ones is it's a statement about the ability to turn. So for example, copper will turn green in the air. That is the chemical ability of copper. It turns green in the air. Iron will form rust in the presence of oxygen. So it has the ability to turn into something else in the presence of oxygen. Iron does absolutely nothing in the presence of nitrogen. So that's the inability example right there. So all these things here are basically more like statements like this will happen or this will not happen. If these statements would have been turned into like copper is turning green, as you'll see in the next video, that's what we call a chemical change. Really the difference in a property and a change is a property is it's more of a statement about the substance, whereas if we talk about changes, it's actually happening. So if I say iron is rusting, that's actually happening, so it'd be a chemical change. If I just say iron will form rust, that's saying it can do it, or that's the ability to do that. So that's what a chemical property is. So again, basically, chemical properties are just a statement describing if a substance will react or not. So here's some practice ones here. Why don't you try to answer these questions first. Go ahead and answer the questions on Edpuzzle, and then when you're done, see the answers when you're done to see how well you did. Okay, so properties of copper. If copper is reddish and brown and shiny, that would be a physical property. A physical property of what copper looks like. Copper forms green copper carbonate. Well, copper can do that, turn into something else, a new substance, so that's what we call a chemical property. The density of copper is this. That'd be a physical property because it's just that's what copper's density is. Copper is a good conductor of heat and electricity. Again, that's just a physical property because we're not changing what the copper is. It conducts well. Copper has a melting point of 1093 degrees Celsius, pretty high. That's its melting point. It's a physical property because it's just saying that's when it's going to melt into a liquid. Copper forms a deep blue solution in contact with ammonia. Whenever things change color, that's kind of a key there. Changing color probably means a chemical something is happening. In this case, this is a chemical change because we're just talking about the ability to change into something else when it contacts with ammonia. All right, good. Lastly, both physical and chemical properties do depend on the specific conditions at which you measure them. So for example, the temperature you measure them at and pressure. We'll talk more about pressure later this year, but those are two conditions that you want to be thinking about when you make your measurements. So for example, looking at water, which is H2O, if you are at a temperature below 0 degrees Celsius, water does not exist in the gas or liquid phase. It exists in the solid phase. So water is ice, solid, when temperature is below 0. And at that temperature, below those temperatures, ice has a density of about 0.92 grams per cm cubed. However, when water reaches a temperature of 0 and all the way to 100 degrees Celsius, in between those two barriers, water becomes the liquid state of matter. So the property of state of matter is changing based on temperature. And so is the density, as you can see here. And if you go too hot, above 100 degrees Celsius, water becomes a vapor, water vapor, or becomes a gas. And you can see the density changes quite significantly too. It goes very, very small when you get there. So the big take-home message here is the conditions at which you look at the properties, they do depend on those conditions. So the temperature and pressure can influence what state of matter something's to be. It can influence its density and so forth. So that's your quick video on chemical and physical properties.